So now the example I'm going to do is actually a pretty famous example. It was actually on a master's exam that they had at my school, and almost everybody got it wrong. Even though realistically we can cover it in the first part of an intro section on probability. It's that counterintuitive of a result. So here's the setup. It's pretty simple. We're saying a famous king had a sibling, right? So had a brother or sister. And our job is to figure out the probability that that king had a sister. That's it. Pretty simple setup. It seems like everyone would just jump at, well, it's 50-50 chance of having a brother or a sister, so it's a half or 50%. And that's where it's wrong. Okay, so I don't think I would be able to convince anybody that it was wrong without carefully writing out the sample space and carefully showing how to get the real probability out of this. Otherwise, I'm not sure you would ever believe me. So again, that's part of the point of doing all this slowly and carefully, is that we'll get to the right answer. And this isn't some like theoretical thing. This is like, right, like if we just bring this problem into real life, right? So this is a situation where there's two kids in a family, basically, like two kids. I look at a million families with two kids in it, where one of them's a boy, and I want to see what's the probability that the other one's a girl. This probability that we're going to find is going to be the right answer. Okay? So, and again, instead of thinking about this as two children, just like we did with two flips of a coin, I'm going to think of this as one child and then the other child, right? Because the king has a sibling, that means the parents must have had two kids. Okay? So, here's the first child, and that could be a boy or a girl, right? A brother or a sister here. And then let's look at the second, which would be a boy or a girl. Okay. So that's how we make our tree diagram. Let's write out our sample space. So that's going to be this top one, boy, boy. Then the next one, boy, girl. Then the next one, girl, boy. And finally, girl, girl. Okay. And I want to find the probability that the king has a sister. Okay? So I'll just write it as the letter S for my event of having a sister. So let's go through here. Well, the king having a sister would mean that the parents had a boy and a girl, right? So there's a boy and a girl here. That counts. And there's a boy and a girl here. So that counts. That's the only one. So then the probability that the king has a sister is 2 out of 4, which is a half, which I just said was wrong. So what did I do here? You may have already figured this out. I just said a king has a famous king has a sibling. Is this possible? I said he a bunch here. King. They couldn't have had two girls. These others are at least possible. This one is not. By knowing that one of the two siblings is a boy, we've kind of changed things. It's actually 2/3. I am not going to intentionally trick you with famous examples that even statisticians get wrong the first time they work on these. I just want to point out how what really seems like a simple problem gets counterintuitive really fast. I am sure that if I just told you at the beginning this was 2/3, you probably would not have believed me. But it is 2/3. These are the two possibilities. Out of 3 possibilities of 2 siblings where one is a boy, it's 2/3. So again, I'm not going to put this on your exam or anything like this. I just want to point out why we're doing this whole tree diagram, sample space, and everything. We can clearly show what's going on and walk through any mistakes in our logic in a fairly straightforward way to actually convince ourselves that what we've got is the right answer. Your problems will not have a little trick like this in it. But again, this is the point of doing all this, is just to make sure we don't make those mistakes.